We have a practice midterm right here. It's almost identical to the actual midterm. It has tons of questions. The midterm itself is only 20 questions. So as you can see, there's several duplicate types of questions. I want to go for the odd ones. I want to explain the odd ones. You guys could work on the even ones if you want, or just studying the odd ones should prepare you for the actual test itself. So on this first section, they want you to add f of g of x, subtract f of x with g of x. Anyways, let's just start with each of them. Let's do f plus g of x, and that would simply be adding this guy with this guy. So this is adding them, right? We have the f of x function right here. We have the g of x function right there. We are adding them. And I put parentheses here because it's important to have these parentheses if this were a minus sign, but it's a plus sign. So you don't even really need the parentheses. It's just combining like terms. So let's combine the terms that are alike and get our answer. The first term will be 5x squared. Then you combine your x's. We have a positive 7x, and we have another positive 7x, which is a positive 14x. And of course, the 12 and the minus 3 is 9, right? 12 minus 3 is 9. And that's your answer for adding the f of x function with the g of x function. It might be better if I start using colors, right? I'll do the f of x in blue and the g of x in red. So now let's do f minus g of x. Let me do that over here. There it is. Here's the notation. That's just notation. I want to do this one in blue, this one in red. So right here, it is very important that we put these parentheses around that red one, around the g of x, because you need to distribute the minus sign. So when we distribute the minus sign, this will become a negative 7x. This will become a positive 3x. So envision that you have a minus 7x and a positive 3x right here. So let's combine, or let's start with the highest exponent term, which is 5x squared. There's nothing to combine that with, so just bring that down. That's the first part of your answer on f minus g of x. And then you move on to combine x's with x's. There's a positive 7x and this negative 7x. Those completely eliminate. And then combine the 12 with the 3, and you will get plus 15. And that is your answer to f minus g of x. Now let's go for f times g of x. And I am running out of space, so I'm going to start working up here. You guys could work on a separate sheet of paper or on a different, or just anywhere it fits. We have f times g of x. So the f of x function, again, I want to write it in blue. And I want to write the g of x function in red, and we are multiplying them. That's why I'm putting them in parentheses. And that's 7x minus 3. So we have a distributive property problem. This does take some work. It does get a little ugly. I put this rectangle here for the sake of space, all right? Let's distribute 7x times 5x squared, that's 35x to the third. 7x times 7x, that's plus 49x squared. 7x times 12, that's plus 84 with an x. And then we're going to distribute the minus 3. Minus 3 times that 5x squared, that's negative 15x squared. Then we have negative 3 times 7x, that's negative 21x. And negative 3 times positive 12, that's negative 36. Let's now combine the like terms. This is why I lined them up already, so I could combine this x squared with that x squared. Well, before anything, the first part of your answer is 35x to the third. And then we have plus, what is that, 34x squared. And then over here, when I combine 84 with negative 21, that's 63, positive 63 of those x's, minus 36 at the very end. So this would be your final answer to multiplying the f of x function with the g of x function. Let's now go for the division of these functions. So when you have f of g of x, f divided by g of x, so it's as simple as this, guys. F divided by g of x. You're going to write your f of x function up on top and your g of x function on the bottom. And since they're not divisible, that would be your answer. Okay? This is your answer. But there's one other important detail. That detail is that you can't end up with a 0 in the denominator. So if you think about that, in addition to this answer, you have to say, but x cannot be 3/7. Now, why do I say 3/7? Because if I did say 7x minus 3 equals 0, and I added 3 and added 3, I'd get 7x equals 3 divided by 7 on both. And we're talking about a value that it cannot be. So it cannot be 0, cannot be 3/7. So you have to include that into your answer. So I am sorry, this one, it's so easy because you can't really divide it. Simply one function over the other, and then state that your denominator cannot be 0, and figure out what value that would make it 0. So that was question 1. 5 minutes on one question. Let's jump to question 3. They want us to find g of f of x and h of g of x. And there's a typo on that one, I'm sorry. This one should say g of h of x and h of g of x. I want you to plug one into the other and then the other way around. So let's do g of h of x, which means we're going to plug in the h function into the g function. So we're going to take the h function and plug it into this x of the g function. So let's do so by rewriting our g function, which is negative 2 times x. And we're simply going to plug in that x squared plus 3x plus 2 right in there, which means that g of h of x really is negative 2x squared minus 6x minus 4. There's your answer for g of h of x. Now let's do h of g of x. So h of g of x. So this time we're going to take the g of x function and plug it into the h function. So we're going to take our g of x function, which is negative 2x, and plug it into our h function just into the x spots. All right. So let's begin by writing our h of x function, but instead of those x's, put parentheses. So I want to say x squared plus 3x plus 2. And we're plugging in the actual negative 2x, the g of x function, into those parentheses. Negative 2x right in there and negative 2x right there. So when we work this out, we have negative 2x in parentheses squared. That's negative 2x times negative 2x. That's positive 4x squared. And we have positive times a negative. That's a negative 6 with an x. Bring down the plus 2. And we are done. H of g of x is 4x squared minus 6x plus 2. So I'm guaranteeing you guys at least one of each of these questions are going to pop up on the midterm itself. Going on to number 5. Make some more space. Oh, hold on a second. I'm sorry. More space. Let me see. Number 5. It's saying find the inverse of each function. So remember, f of x is really the same thing as y. And to find the inverse, you switch x and y and then solve for y. Okay? So you really have an x equals 7y minus 10 over 30. You just simply magically switch that y with that x. Nothing else changes. You just switch them, and then you solve for y, which is in this fraction on this numerator. So let's get y by itself. First, by getting rid of this divided by 30, by multiplying both sides by 30. So that would cancel out. You'll have 30x equals 7y minus 10. And then to get y by itself, you would add 10 to both sides. You can't really add 30 plus 10 because it's a 30x plus 10, so you're going to rewrite it. 30x plus 10 equals 7y, which means 7 times y. And to get rid of that multiplication of 7, you're going to divide by 7. And when you do to one side, do to the other side, divide the other side by 7. So there is your answer. Y equals 30x plus 10, all divided by 7. And on the multiple choice, you're probably not going to see the y. Since it was given to you as a f of x, they're going to show it to you as f with that little negative 1 up there. Inverse. Number 7, another inverse function. We have y equals x over 3. What do? We switch x and y. So we'll have x equals y over 3. Then we solve for y by getting rid of that divided by 3, by multiplying by 3. What I do to one side, I must do to the other. 3x equals y. There's my inverse. Y equals 3x. Moving on to number 9. State the domain and range of each. Well, in order to understand domain and range, we need to go back and remember what a square root function looks like. Okay, And I hope we remember that the parent graph of a square root function, y equals the square root of x, that one has no h or k value, okay? But what does it look like? I hope we remember that it looks like this, going in that direction, okay? If you forgot, you could always make a quick xy table and plug in nice values for x. Like the square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3. So if you think about 0, 0, that's at the origin. If you think about 1, 1, that's right here. If you think about 4, 2, 1, 2, 3, 4, 1, 2, it's right there. If you go to 9, 3, it'll be right there. So that's what it looks like. That's what your parent graph looks like. So any other type of square root function, doesn't matter what kind of graph it is, it's going to be some type of modification of this one. And we should all know that the h and the k value, this is a shift left and right. This is the shift up or down. And the a value out here, since it's negative, would cause a reflection over the x-axis. So let's think about this. Let's go through the transformations. The negative sign out in front would mean that it would reflect on the x-axis. And so it would look like still starting at 0, 0, but going this way, right? And the shift h is a positive 3, think opposite, which means you're going to shift 3 to the right. And the k value is positive 1, which you're going to shift 1 up. So let's take this new function that was at 0, 0, that was reflected over the x-axis going this way. Let's shift this guy 3 to the right and 1 up and put our new dot right here, but it's still going to be going in that same curved direction. So the coordinate, the beginning part, should be at 3, 1. Write that down, or let me graph it in green. 3, 1 would be right here, no, right here. And it would still be going down in this direction forever. So this beginning point is actually the coordinate hk, which is 3, 1. And we know it actually starts right there at 3, 1, okay? And the whole green graph is below 3, 1, and it's to the right of 3, 1. So when we're talking about domain, we're going to say that the domain is x must be to the right side of 3, and it's including that 3, so greater than or equal to 3. And the range are your y values, and we said that this whole thing is below the coordinate 3, 1. It starts at 3, 1 and it's below 3, 1. So we're going to say y is less than or equal to the y value of 1 on that beginning point, coordinate 3, 1. So that's your domain and your range. Let's move on to number 11. Well, this is definitely not a square root function. What kind of function is this? What does it look like? Obviously, the exponent is a variable, so this is an exponential either growth or decay function. What do you guys say, growth or decay? Decay, because the b is less than 1. If it were greater than 1, it would grow from left to right. It's a decay factor of 1/2, which means it's less than 1. It's going to decay from left to right. So just a quick sketch. All decay functions start up here somewhere and just decay down to the asymptote, which is nothing in this case, right? If your a value were negative, it would flip, right? It would reflect over the x-axis. It would be like this. But it's not negative, it's positive. The only thing that 4 does, it causes a vertical stretch, but it's still going to look in that same manner right there. Okay, it just might be a little steeper. But either way, it's still going to be opening in that same manner. And we do have a h or k. We don't have an h. H is 0 because the h value is always being subtracted from the x, which would imply that you have a number up here in the exponent being subtracted from x. And the k value is 1, so the k value equals 1. So if I did take this parent graph and did my shifts according to 0 and 1, the h and the k value, you would have a new asymptote no longer at the x value or at the x-axis, which is the y value of 0, but at the y value of 1. I hope you remember that the asymptote was the equation y equals your k value on exponential growth or decay functions. So let's say that our 1 value is right here on the y. So your new graph, which I want to do in blue, is going to look like this, that infinitely approaches that value of 1. It got shifted 1 unit up. So knowing that your exponential decay function infinitely approaches the asymptote y equals 1, that means it never actually gets there, just infinitely approaches. What is the domain and range of this blue graph? The domain, the x values, are all real numbers. That's absolutely right. because even though it curves up, it does continue to go to the left forever. It'll just be way up there off the graph. And it does go to the right forever, so x equals all real numbers. The x value of this blue graph go to the left and to the right forever. X equals all real numbers. The range of the blue graph is y. The y values are all above the y value of 1. Not or equal to, because that would imply that it actually touches the asymptote, and it doesn't touch the asymptote. So y is greater than 1, not greater than or equal to. So there's your domain and range for that exponential decay function. All right. Moving on to question 13. Is number 11 an exponential growth or decay? I don't know. We just did that one. We just said it was a decay. And why is it a decay? Because the base is 1/2. It's less than 1. That's right. Then the next one is 12, an exponential growth or decay? Growth. Why? Because the base is 3. It's greater than 1. It's going to cause it to grow. Excellent. So we're going to stop this video right here. That was the first page of our practice midterm.